Hey gang, welcome back. Today's video is going to focus on solving one-step equations. And we're going to do this first off focusing just on addition and subtraction one-step equations. So take a minute and look at the 6 problems given to you. All right, I know I'm not giving you variables, but realistically, shapes also classify as variables as well. We don't always have to use numeric letters. So I want you to take a second, pause the video, and see if you can't figure out what the missing values are for each of these 6 problems. Once you've looked at these 6, hopefully you found that the first one was a 9, second one, 82, the red square should have been 37, your purple trapezoid, 96, we have the hexagon at 35, and the pink arrow, 24. Okay, so let's talk about where this actually goes, all right? And the picture idea does sometimes help people here, so that's why I'm showing you a couple. In an addition equation, we could be given a problem such as x plus 5 equals 11. And what your goal is for any problem of this sort is to find out what number, when you substitute in for the x, makes it true. All right, so some people like to think of this balanced scale idea. So what I have here on the left is I have 5 blocks representing our positive 5. And then we just put one large X box to represent the missing value. We know that that has to remain balanced with this side that has 11 blocks. So if you think of the picture idea, you can now see we have 1, 2, 3, 4, 5, 6 blocks being added to the 5. So hopefully you do see indeed that your answer should be 6. For the letter X. Now notice in the answer that I drug over, pictures weren't involved. All right, what did I do? Well, I saw that I was adding 5 to a certain amount. What I can do algebraically is I can take that negative 5 and do the opposite. I'm going to subtract 5 away, but with an equation, you always need to remember what you do to one side of the equation has to be done to the other side of the equal sign as well. So subtracting 5 from both sides, on the left-hand side we have a 5 minus 5. Well, those are opposites. They cancel each other out or equal 0. So x is the only thing left on that particular side of the equal. Then we're left with 11 minus 5. We can definitely see that 6 is our answer. So you can think of the picture if it helps you, or you can go straight to the algebraic form, all right, which is the goal of this review. Okay, so looking at the pictures here, write an equation for that first one, just like we did in the previous slide. On the left-hand side here, I have an x, and I'm adding 3 squares. On the right-hand side, I have 1, 2, 3, 4, 5, 6, 7 squares. So from this point, you should be able to solve for the x. Similarly, on the other picture, on the left-hand side, we've got 1, 2, 3, 4, 5, 6 squares. 1, 2, 3, 4, 5 squares. You could write it as a 6 plus 5, or if you are already feeling confident, which is great, you can say we have 11 squares. On the other side, we clearly have an x. And to that, we are adding 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Once you have your equations written for the situation, you can go ahead and solve and see that you can easily check them as well. If you have questions on these, make sure you come in and see your teacher so we can get you squared away. Pause the video at this point. Make sure you have these problems copied down for your notes. How would you solve the first equation? X plus 21 is 34. Again, plus 21 is attached to that variable. We would really like for that variable to be completely alone. So to get rid of a plus 21, you want to think of doing the opposite. So if I look in my choices of A, B, and C, the only one that I see doing the opposite of adding 21 would be letter B. Letter B shows that we're subtracting 21 from both sides. And once we subtract 21 from both sides, you should see that 13 would be your answer for letter X. We can also do the same procedure with subtraction. In this first example, we're given x minus 9 equals 47. Well, think about that. I want to isolate the variable, get it alone. So that means a minus 9 needs to go away. The way we're going to make it go away, do the opposite. We're going to add 9. Similarly with the second equation, x minus 51. Again, get the x alone by adding the 51 to both sides. And when you do so, this is what should occur. So in our second one, add 51. Again, add 51 to the opposite side of the equal sign to get your answer of 84. Two more problems for you to try with adding to both sides to get rid of that minus sign. And just to save on some time, if you need to pause the video to get this copied down, by all means, please do so. Okay, so one-step equations not only include addition and subtraction, but they can also have multiplying and dividing. So we're going to take the same idea, get away from the pictures, things like that, and just focus on doing the opposite operation. So with number 1, when we have a number and a variable written next to each other, like 8s, hopefully you remember from your previous math lessons that that indicates multiplying. What we're really asking is 8 times what equals 72? Again, try and do these without a calculator if you can. So think back to your times tables, all right? Or you can go with the opposite operation. Opposite of multiply is indeed divide. So if I take my 72 and divide it by the 8, hopefully you find that S should equal 9, because 8 times 9 is 72. To show this, showing your work in the problems, which you should definitely get into that habit now, notice 9 times Q. Instead of times 9, we're going to divide by 9 because it's the opposite. 9 over 9, that always cancels when we have the same number over itself. So Q is the only thing on that particular side. 27 divided by 9, we know is 3. It doesn't matter whether the variable is on the left or the right. If you prefer it on the left, like some people do, just go ahead and rewrite the problem. So for number 5, I would rewrite that as a 6x equals 48. You can do that at any time. Now, because we have times 6, we're going to get rid of it by dividing. 6 over 6 cancels out. So x is all alone. That's good. 48 divided by 6 gives us an 8. Make sure you pause the video at this time and copy down examples 2, 4, and 6 in your notes and try those on your own. If you have questions, bring them to your teacher and we'll be happy to help you through them the next time we see you in class. Okay, so moving on, you're also going to, at this point in the game, start getting some word problems. Everybody's favorite. So let's just do a quick little review. Match the equation with the phrase. Our first phrase says $7 per hour for a total of $21. All right, the word per indicates multiplication. So what we've got here is if we take 7 times the number of hours, we're going to get an answer of 21. Next phrase, Jupiter has 18 moons. This is 2 times more the moons than Neptune. Well, we know our answer is 18. All right, we know that the answer is found by taking 2 times more moons than Neptune. So taking a look here, this one seems to tell us that 18 is the answer from 2 times a number. So that's definitely the one we want. The last one, the distance between Little Rock and Benton is 24 miles. This is triple the distance between Little Rock and Maumelle. Hopefully you see that triple the distance. Well, we don't know that distance between Little Rock and Maumelle, but if we take triple it, we're going to get an answer of 24. All right, so now let's take this and try one on your own. A hot air balloon flew at 10 miles per hour. Using the variable h, write and solve a multiplication equation to find how many hours the balloon traveled if it covered a distance of 70 miles. Okay, so let's take it piece by piece. The balloon flew at 10 miles per hour. Again, remember, per means to multiply. So if I take my 10 miles per hour and multiply it by how many hours we've flown, in science class you're going to go over this equation as well. Rate times time equals distance. We know the balloon went 70 miles, so now multiplying by h to get rid of that, we divide by the number attached, and you get an answer of 7 hours. Okay, in the home stretch, let's try the same thing, but now I'm going to give you problems that show division. So hopefully you found the pattern by now. We're going to do the opposite to get the variable alone. So in the first problem, we have x, fraction bar means divide. So because I'm showing you divided by 5 attached to it, we're going to do the opposite, and we're going to multiply both sides by that 5. That way, opposite operations cancel out, and we get an answer of 40. Same thing here. What the question is really asking is what number divided by 10 equals 12. Easy way to find that, do the opposite. Multiply both sides by that 10, and m equals 120. Okay, last one. Be careful with your negatives. S divided by negative 3, well, we're going to multiply by a negative 3. Those are going to cancel us out, which gives s alone. Negative 7 times a negative 3. Negative times negative is positive. They are going to cancel. 7 times 3 gives us 21. So again, one-step equations, very short, not a lot of scratch work to do. Right? If you're having questions at all, please come see your teacher as soon as possible so we can get you back where you need to be. Have a great day.